Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 11. Given two resistors R1 and R2 connected in series in circuit 1 and in parallel in circuit 2 across identical batteries of terminal voltage V with some internal resistance. A third unknown resistor R3 is added in series in circuit 1 and in parallel in circuit 2. We need to answer the two sub-questions based on this above information. Part A, does the current in the battery increase, decrease, or remain the same in each of the two circuits? Give a reason for your answer. So we have connected a resistor R3 in series to R1 and R2 in circuit 1 and in parallel with R1 and R2 in circuit 2. So the circuit diagram would be something like this. That this is the circuit diagram that we have derived from circuit 1 and this is the circuit diagram that we have derived from circuit 2 after applying a third resistor R3 in series in circuit 1 and in parallel in circuit 2. We need to tell what is the effect of adding the resistor in each of the two cases on the current drawn from the battery. So we know that current I drawn from the battery is V upon R. Since adding R3 increases the total resistance of circuit, we can say that I will decrease in circuit 1. We can see that I, it is inversely proportional to R. Increase in R will decrease I. So the current drawn from the battery will decrease in circuit 1 on addition of a resistor in series. For circuit 2, when we add a resistor R3 in parallel, the circuit will be something like this. And now the total resistance for the circuit decreases. As we have added a resistor in parallel, equivalent resistance of R1, R2 and R3 would be lesser than as that of equivalent of R1 and R2. Since R is decreased, the value of current drawn from battery will increase. So in this case, when you add a third resistor in parallel, the current drawn from battery will increase. Let's take part B as well. Does the terminal voltage of the battery increase, decrease, or remain the same in each of the two circuits? So first take circuit 1. We know that the terminal voltage V, it is given as the EMF minus I times the internal resistance of the cell. And we have been given, you can see that the voltage V, it has some internal resistance. It has some internal resistance. It is given over here. So as we know this, that internal resistance is there in the circuit, we have to write the formula for the terminal voltage as EMF minus I times R. Now, since the current is decreased in the case of series resistor, when we have added R3 in series, I gets decreased, and now V is equal to E minus IR. So I is decreased, I multiplied by R, the lesser amount of voltage drop is getting subtracted from the EMF. So we can say, so the terminal voltage V will increase when a third resistor R3 is added in series. Let's take the case for parallel as well. When we have added the resistor in parallel, I has increased. because the total resistance is now decreased. So again, the terminal voltage will be E minus IR. And since I is increased, now more amount of potential drop is getting subtracted from the EMF. So E will decrease. V will decrease in case of the parallel resistor. Thank you. Keep learning, keep practicing, keep excelling.